Minimum cost climbing stairs. So this one is a dynamic programming question similar to the last one that I did. You are given an integer array cost where cost I value is the cost of the I step on a staircase. Once you pay the cost, you can either climb one or two steps. You can either start from step with index 0 or step with index 1. Return the minimum cost to reach the top of the stairs. So we need the lowest cost that will get us to the top of the stairs. And we can only take one or two steps. So let's copy these two so we can keep these two in mind. Very important for this problem. Got on. So index example one input cost our cost list, and we need the cost that will get us to the top here. So here we can either start at one or two, and that would be the lowest here. So we can start at index 0 or 1, like it says over here. So if we start from here, then we'll have to add these two, and that will be 15. Or step one, if you take one step from here to here, that will be 15. Or two steps from here, that will be 13. So this one is lower, but still lower than this. And then we have to, and then here we can just come here. We can just start index 1 and 15 and take two steps here, and that will be 15 instead of adding these two, and that will be 25. So one step from here, start index 1 and then take one step outside, which will be the top. So it doesn't show that the top where the top is, but the top is basically um, outside the last value. So we have 15 here. That's the lowest cost. Here is 6. So basically, we're going to take go all the way from here to here. With the lowest cost, we have a bunch of ones, so which will end up adding up to 6, as we can see. But I'll use this example to demonstrate on how we got 6. So let's start with our base case. So let's make our end, let's call it len of cost, our cost list. So basically this will be the whole value. So from here to, so this will end up going all the way to the top value, because the length of this is 0, 1, 2, 3, but we're going to start at index of 0. So this is basically to make sure that we get to the top. So if n is equals to 2, return the minimum of cost 0 index, or cost the value 1 index, whichever is lowest, if we only have 2. So if you only have 2 values. So now let's initialize cost. Initialize integers, no, variables for our pointers. So let's make first initialize it and equals to cost 0 index. We'll use this for our loop. So, no, second equals to cost 1. So now let's make our loop. So for I in the range of 2 to n. So these two, we only make sure that we have 2 values. So whenever we pass these 2 base cases, so meaning we have 3. So we start from here, 0, 1, 2, index 2, range uses our index. So and then let's make our current value, which will be current is equals to the minimum value of first or second plus plus current cost of I. So the I value is cost. So in this case, for the first iteration, after we make it out of this base case, it will be 0. It will be 1 here. This will be the 1 value here, and then first will be this one over here, and second will be this here. And then so it will take the lowest one, which is going to be the minimum, which will be 1, and then add the cost value, which will be 2. So we get 2 will be, so after adding up 2 will be the thing, will be the current value. So let's make our first value equals to our second, and then make our second our current. Second equals to current. So now this will be our second value. So now let's return move out of the loop, and then minimum first or second. So this will basically choose, it's basically this one over here, but we'll choose the lowest value here, since we need the minimum to reach the top, as it shows over here. So it will keep going by each one. So the next iteration, so this one is 2, since we add these 2. So this one will be, since this one is, hold on, this one will be the next target in I, which will be at 3, index 3. So these two will be, this will be our first, will now be second. Over here we're going to move this first over here and make our second 2. So will be second will be the current value 2. Yeah, 2. Okay, so now we're going to add these. Hold on. So this will be 1. This will be first, no. So first, okay, no. So this will be 100 will be here, and then so the cost I will be 3, 100, and then this one was 2. Yes, what was it again? 1 plus 1 is 2. Yes, 2. So 2, and then I is here is 1. So we're going to add 2, since 2 is lower than 100, is the minimum here. So 2 plus I will be I value, which is 1, will be 3. So now this first pointer will now be our second pointer that it was. So now it will be this one over here, our past pointer, which was 2, and then this is 3, And so now our second pointer was now our current value, which is 3. For this second for the iteration with at index 3, and then 100, this would be 3. So next iteration will be so on until we get 6 over here. That's basically this. It's a simple code, and it's a follow up to the last similar question, climate test question, and that's it for this one. Let's submit it to see if it will pass. No, let's run it fast to see if it will pass all cases. Boom. And it's been able to pass the 2 cases, and the time complexity is O of n, since and the length of n increases, iteration needed. Our space complexity is O of 1, since our variables are constant with no additional space needed. So let's submit it to see if it will pass all cases. And it's been able to pass all cases efficiently. And that's it for this problem.